Dear learners, in this video, we are going to study the Barkhausen criteria for sustained oscillation. We know that we can use a transistor as an amplifier as well as an oscillator. The required thing is that we need a feedback circuit for both as an amplifier as well as an oscillation. But the type of feedback is different in both. In an amplifier, we use negative feedback, and in the oscillator we use positive feedback. What feedback is? So here if there is V input, say it is not 0, so we are having some input Vi and we are getting some output without feedback, and the output is given by A times V input, where A is the gain of this amplifier. Now, if we connect a feedback circuit, what will happen? This feedback circuit will extract some amount of voltage or signal from the output, and it will uh, feed it back in the input. It could be of two types, positive and negative. In the negative feedback, what happens is that the output of the feedback network is out of phase with the input of the amplifier. Then that means the total input decreases. But in case of positive feedback, what happens is that the output of the feedback circuit is in phase. That means if the input is like this, the output is also with the same phase, and this will increase the input because this input from the source and the input from the feedback circuit will be superimposed to give us a larger input, and we will receive a signal at the output where the oscillations will be having increasing amplitude. So this I'm talking about the positive feedback. And in case of negative feedback, the output decreases with time. This is time and this is voltage output. So in negative feedback, the output decreases with time, and for the positive feedback, the output increases with the time. Now in an oscillator, what we want that the output should neither be increasing nor decreasing. That means the output should be of this form as shown in this figure. Now there is a term which we call as sustained oscillation. What is the meaning of sustained oscillation? That even if there is no input, we are getting output. That means we will have to apply input only at the starting, and after that, even if we make the input Vi equals to 0, we will get some output, and that will not be equal to 0. Now, Barkhausen gave the criteria. There are two criteria which will lead to this situation. Now, we know that the output, V output, here is equals to A times V input, where A is what? A is the gain of amplifier without feedback. And the feedback voltage is given by beta times V output, because this beta fraction of the output voltage will be the output of this feedback circuit. So I am writing it as Vf equals to beta V output. Putting the value of V output from this expression, we will get A beta V input. So the final expression, that is Vf is A beta V. So now if we want that there should be no input voltage from the outside source, that means Vi has to be 0 as shown here. So from where the amplifier should take its input? That input should be provided by Vf. That means the feedback will provide the input only. There will be no separate input from the source. So we want that the oscillation has to be undamped. That means there should be no reduction in the amplitude. So undamped oscillations are like this, same amplitude with time. So that is possible only when every time we have same input. So that is possible only when we say that the feedback is equals to Vi. So voltage provided by the feedback circuit is actually equal to the input voltage which we provided at the first step. At the first step we actually required V input. And we got some V output. Now that V output will be fed as input with the help of feedback circuit. So this is possible only from this equation when we take the magnitude of A beta is equals to 1. That means Vf will be equal to V input when this follows. Now we know that the gain of the overall transistor with feedback, which we denote by A prime, is equals to A over 1 minus A beta. This I am talking for the positive feedback circuit. So if A beta is equals to 1, what we will get? A prime will be A over 1 minus 1, which is equals to A over 0, that is infinity. So the gain of this transistor with feedback, with positive feedback, is infinity. What is the definition of gain? Gain is actually output over input. So if this is infinity, it is possible only when our V input is 0, and this is what we want. We want there should not be any input source, but the oscillation should continue by itself, and that is done only by the feedback circuit. So we can write here that the oscillation will be sustained even without input source. So hence the first Barkhausen criteria is the magnitude of A, which is gain of the amplifier without feedback, and beta, which is the gain of the feedback circuit. Its product, the magnitude of its product should be equal to 1. In that case, we don't need any kind of input from outside and we will get sustained oscillation. But there is also another criteria. I would write it as the second Barkhausen criteria. And what is that? The feedback should be positive only. That means the phase difference between the output and the input should be not output and input. In fact, the feedback of the phase of the feedback circuit and the input should be 0 degree or 360. That means they both should be in phase. So if we are having input like this, the feedback should also be of the same phase, only then we will receive the sustained oscillation. So in other words, we can say that the feedback should be positive. Now how the sustained oscillation look like? Sustained oscillation will be, if this is the output and this is the time, So there will be no loss, no heat loss or any other kind of loss. So this is all about the Barkhausen criteria for sustained oscillation.